if folks in the chat, if you can hear me and see me, can you reply? Okay, awesome, fantastic. All right, so we are indeed live, and it's great to see everybody. What are we here to talk about? So this is our this is episode 2 of DataStax Dev's live streams, and today we've got a fantastic episode where we're going to talk about how you as developers can vectorize PDFs in order to build really amazing experiences using RAG. And we're going to teach you how to do that using LlamaParse. And then we're going to show you an awesome product called Imprompt that was built using LlamaParse and using Astra DB. Super excited to talk about this. The intended audience for this live stream is developers. So hopefully you all are developers, know how to code. I asked a question in the chat about a preferred programming language. Seen some Python responses, seen some JavaScript responses. This is pretty introductory, right? So if you don't know what it means to vectorize something, if you don't know what RAG is, don't worry about it. We're totally going to get into it and help explain these concepts, and hopefully leave you all with a bunch of fantastic questions and follow-ups that you can kind of take with you after the live stream. So let's go ahead and jump into the agenda. So this live stream is probably going to be about 45 minutes long, plus or minus. We're going to make some introductions. I'll introduce myself, and we'll introduce the rest of this awesome panel. We're going to talk about RAG, like what is RAG, like why does RAG matter, how is it useful. We're going to dive into ingesting documents and data using LlamaParse, and then we're going to run through some code. We're going to show you exactly how you can use that data to build a chatbot experience using RAG and LlamaParse. Then we're going to turn it over to our guest from Imprompt, who we'll introduce in a second. Imprompt is an example, production example of what you can do with RAG and LlamaParse and Astra DB. So we're going to kind of show that off, something that's real, and it's real that people are using right now. And then we're going to get into maybe my favorite part of the talk. We're going to have some hot takes on what it takes to actually go from toys and prototypes and getting RAG into production. So a couple housekeeping notes. And I'm seeing a ton of questions flying in the chat. Keep those coming. We'll answer them as we can. But yeah, so we have a chat on the right. Feel free to introduce yourself. Let us know where you're dialing in from, what your favorite programming language and web stack is. It's a great place to kind of introduce yourself. Another thing I want to note, and by the way, I know that many of you are watching on other platforms. Like right now, we're streaming this on Crowdcast. That's where many of you are watching this. If you're watching this on YouTube Live or LinkedIn Live, that's awesome. If you're on Crowdcast, you will also notice on the right of the screen, there's a box that has a question mark on it. That's an opportunity for you to ask specific questions during the course of the live stream. And if you click on that, you can create a new question. And then just like Hacker News or Reddit, you'll be able to see the questions that people have asked, and you'll be able to vote those up. So if you see that someone's asked a really relevant or interesting question, please upvote it, right? This is going to help us kind of curate a list of questions that we can kind of answer towards the end of the live stream. So yeah, that's mostly what I wanted to cover in terms of housekeeping. The next thing we're going to do is introductions. So here are today's speakers. You can kind of see what we've got on the list, but I'm gonna go ahead and minimize this and let everyone go around the room and introduce themselves. And here's what I'm gonna ask. So obviously, let us know what your name is, what company you work for, what your role is at that company. let everyone know where you're kind of streaming in from right now. And my sort of kind of like fun surprise question, I want to know if you watched the Oscars. And if you didn't watch the Oscars, I want to know what on earth you were doing, because apparently 70 million people watched the Oscars. So I'm going to go first. My name is Carter Rabasa. I work at DataStax. I lead our developer relations team. For the purpose of this live stream, I'm going to kind of be your host and your MC, and I'm going to kind of keep the party rolling. I'm dialing in from Seattle, Washington. About 30 minutes ago, it was absolutely coming down in buckets, but it's calmed down, so it's pretty nice outside. And I totally watched the Oscars. I am very perplexed when I encounter people who don't watch the Oscars, but I am curious to hear what everyone else says. So let's I'll call you out. How about let's go over to Jerry.
Hey everyone, Jerry, co-founder and CEO of LlamaIndex, excited to be here and also, chat a little bit more about RAG, LlamaParse, and thanks to the DataStax and also Imprompt folks for hosting and joining. I did not watch the Oscars. I'm very sorry to say that. I forgot what exactly I was doing. I was probably working on a LlamaParse cookbook or some LlamaIndex related thing. But passing it over to maybe Jeff.
Hi, I'm Jeff Schneider. I'm the founder and CEO at Imprompt. I'm calling in from Los Gatos down by San Jose. And my background is software engineering. Built a consulting company in Austin, Texas, and grew it up through application development and architecture and cloud computing and DevOps, and sold that off to VMware. And then I ran the professional services for VMware's cloud computing for a little bit. I did not watch the Oscars. I had calls. We were putting together some new Sonic branding, right? So that was very fun, very cool. We had some people from Broadway who were helping us to work on some branding material, and I was having a ton of fun doing that. But Alex, over to you.
I'm really sorry, Carter. I also didn't watch the Oscars. So this is just not a good crowd for your secret question. But I'm Alex. I'm also over at DataStax, also based in Seattle, and I'm focused on our ecosystem. So building integrations with folks like Jerry, just very focused on making it easier to use Astra with tools in the Gen AI ecosystem. And do not know when the Oscars was, so not sure what I was doing, Carter. But back over to you.
All right, thank you. I'm not disappointed at all. I think it's fine not to watch the Oscars. I was perhaps hoping for better reasons. But look, it's honestly, the Oscars was full of heartbreak for me. Across the Spider-Verse was totally robbed. So perhaps it's better that none of you had to experience that. I have created a poll in our live stream for folks here on Crowdcast about whether or not you watch the Oscars. Obviously, here on the panel, it is squarely an anti-Oscar crowd, but there are many more of you out in the audience. So let's see what happens. Although, wow, the poll is already not going in my direction. Okay, awesome. So I think we've done some awesome introductions. Let's keep the party going. We are going to transition to, let's see. Now it's time for us to sort of talk about RAG, like what it is and why it matters. And I'm gonna kick this question over to Alex.
Yeah. So before we really dive deep, we thought it was worth kind of talking through like why RAG is necessary. So really, RAG solves an extremely basic problem. Large language models do not have access to real-time data or your company's data. So imagine you are, let's say, an auto parts store. You're building a customer support chatbot for your customers. The LLM won't be able to answer any questions related to your inventory or any specifics of your business. So by using RAG, or retrieval augmented generation, we're able to kind of teach the LLMs about your business so they can then answer these much more advanced questions. So there are two components to RAG. The first is the ingest piece, right? Somehow you need to take, in the auto body parts example, all your inventory, other information on your business, convert it to a embedding, store it in a vector store, like Astra. Jerry will talk more about this piece. And then the other component is the RAG chain, right? So when the end user asks a question, how do we inject the right kind of information on your business into the prompt that the LLM can then provide a good response. So we'll kind of walk more through this process, but really RAG is super necessary for, oops, sorry, I'm getting the Slack message. RAG is super necessary for giving the LLMs kind of important knowledge of, your business. Cool, and I'll hand it back over to you, Carter.
Yeah. All right. So awesome. That's a really fantastic overview of like why RAG matters and like why it's such a useful technique for developers when they're building like intelligent and like accurate and good sort of AI, generative AI experiences. Okay, I mean that makes sense to me. But then like why LlamaParse?
I'm assuming this is for me. So I think as Alex said, RAG is one of the key ways to basically feed external data into a language model. And a big use case for, a big example of this external data is, for instance, like your documents. For instance, you might have a lot of PDFs within your organization. You might have other files like docx files, Excel sheets, PowerPoint slides. And of course, there's also an infinite number of other unstructured data sources that you can connect to as well. Some popular choices include Notion, Slack, and Discord, like Google Docs, Salesforce, etc. So for the purposes of this discussion, we'll probably stick to documents. And if we just think about how do we get the LLM to really understand the documents within our corpus, then you realize that you need a few steps basically to make this happen. One is you need to actually load in the text from these documents in some way that, that the LLM can understand. And it turns out this issue can be solved with some open source tooling as well. Like there's plenty of open source PDF parsers, ways that you can just easily extract out text from these documents. But it actually falls apart for some more complex documents. So for instance, like if you have a PDF, oftentimes these PDFs can be arbitrarily complicated. They can have tables, charts, figures. They can have different columns, sections, and headings and those things. And so LlamaParse is actually a proprietary parser that we built at LlamaIndex that's designed specifically to understand documents of any complexity and extract that text in a format that the LLM can understand. And it's a pretty big step towards being able to get LLMs to reason over your data, regardless whether or not you're doing RAG, retrieval, or just directly feeding that into the LLM. But in any case, in this setting, and especially in some of the demos that we're going to show, we're going to take these PDFs from an example corpus, so load it through with LlamaParse. So that's a key stage at the beginning of the system, so data loading. And then we're going to show you how to process it through embeddings, vector search, and put it into Astra DB, and then build your query pipeline on top of the documents that are stored in the vector database. And so we'll show you how to build this end-to-end pipeline and actually do it over some interesting documents. For instance, like the annual report of Uber, which contains both text and also tables, and show you how we can basically answer questions over both types of that data, regardless of what, regardless of whether it's unstructured or structured, and actually compare it against a baseline.
That's awesome. I mean, dude, we should just like dive into the demo.
Yeah, sure. Sounds good.
All right. So I'm going to get this slide out of the way. And Jerry, you should just feel free to share your screen.
Let's do it. So I am going to show a live demo of how to use LlamaParse, LlamaIndex, and also Astra DB to basically build a RAG pipeline. And we'll actually compare it against like a rough baseline of like a open source PDF parser with something like a bit more of a naive indexing and retrieval pipeline. And so we'll basically show how actually using LlamaParse plus some of the more advanced capabilities within LlamaIndex gives you better results than doing something a little bit more basic. So the first thing is we'll take a look at the data source. These are just a set of installations you can run through. With LlamaIndex, we actually factored out all the integrations into separate packages. So we have LlamaIndex core, which is the core logic for basically orchestrating RAG agents and a bunch of other things. You can pip install the OpenAI embeddings, as well as any sort of like re-ranking module. And then you can also pip install LlamaParse. So that's a client library that actually hits. LlamaParse is hosted on our cloud servers. But this is basically a client library that allows you to easily upload local files to it. And then we also pip install LlamaIndex vector stores Astra DB. The main document we're going to be using is the Uber 10 Cube March 2022. So if we take a look at this, there's a bunch of documents in here, but I'm just going to show you what this looks like. Okay. And so you can see this is, this has become like a pretty popular document for testing like RAG and LLMs in general, just because like these SEC filings are one, public documents, and two, they can be very long. So this is 106 pages. And as you can see, this contains a bunch of text formatted in different ways. Like here's the title, here's the table of contents, here's a bunch of text, and then here's an example of a table. So here's, for instance, like the consolidated balance sheet as of 2021 and also 2022, right? And you can see it just is a very interesting use case because there's a bunch of different types of information within this type of document, which makes it a nice testing ground for something like LlamaParse, actually. So we already downloaded this. Here's my OpenAI key hidden in that cell. And what we're going to do initially is just to initialize some basic parameter settings, right? And so in this case, we're just going to use OpenAI. We have like dozens of different embedding and embedding and LLM integrations. So you can use local models if you want. You can use Anthropic, but in this case, we're just going to use OpenAI. So we're going to use their new embedding model, text embedding 3 small, and then also GPT 3.5 turbo.
And hey, Jerry, I'm gonna sort of interject just every now and then. I'm sort of my job here is to sort of like represent the people in the chat. When certain like real time questions come up, I'm assuming that we'll be able to share like these code like collab notebooks like after the chat, right?
Yeah, I'll paste a link in the chat afterwards. This is all available in the LlamaParse client repo. We have a bunch of notebooks.
Awesome. Cool. All right, man. Keep going.
Yeah. And so we basically just set these as global settings. So you have, the LLM, you set it right here, and then you have the embedding model, and you set it right here. And this basically just means you don't have to pass this into any of your downstream modules anymore. So it's more of a convenience setting. Next, we're going to use LlamaParse to actually load in this data. And so what's going to happen is we're going to take this PDF and actually just send it to the LlamaParse service to run over. It should actually be cached. So yeah, this actually takes a relatively short amount of time. If you upload a new document, it might take a little bit longer to process. And it's also a function of how complex and big that document is.
Jerry, what are the other result types that you support?
So we support, I can show you actually. So we support markdown, which is what is shown here, which is you can basically see, this is roughly a markdown formatted text, and then this directly feeds into our markdown parser. It also, if you just want something that looks pretty, we can do text too. This might take a little bit of time because oh no, it's okay. So and then this will pop more if I show you something like this. You'll see it basically formats everything with nice spaces and stuff. And I know you can't really see this, but this pops more if I zoom out.
Yeah, and are you choosing Markdown not necessarily because of what you're trying to accomplish, but because it just demos better for this?
Like no, I'm doing Markdown because it helps me accomplish things.
Oh,
yeah.
Okay. Awesome.
Because the text looks pretty, but it's hard to parse because there's no structure to it. We have Markdown and also JSON mode, which JSON mode is a little bit of a separate notebook. I can show you that as well, which will return stuff in a semi-structured dictionary. By adding structure, it gives you better capabilities to define your own parsing algorithms on top of it. It better integrates with our own parsing algorithms that can extract out tables cleanly from the text. Right. So as opposed to just like looking pretty, it actually gives you the ability to better process it down the road. So this is what the markdown format looks like. This is financial information, financial statements, consolidated balance sheets. And so this is actually what the table looks like. You can see it's less pretty than the pure text render, but what this is actually a markdown representation of the table, right? The bars and the horizontal lines just means this is like how you format stuff in Markdown. And what this allows you to do is you can basically now use a Markdown parser to parse this out into a structured data frame. All right, so here's just some more examples. I think our table recognition capabilities are quite good, I will say. So just a heads up in terms of the things that we support, and I'll give you a sneak preview of what we're supporting. We're actually launching a big update tomorrow. We do support JSON mode. So if I just go into here, this notebook basically shows you, hey, we use Anthropic right here. But this notebook shows you how to basically get back a JSON result. So this shows you how you can, instead of like getting back a markdown text, it'll give you back a list of like structured dictionaries. And this actually lets you parse out images from the document. I know I'm not running it here. Maybe there's an example here actually. Okay, that's not the best example. But basically, you can extract out images and then actually use a multimodal model to run over it to basically extract out information from those images. Nice. Okay, I'm going to go back into this notebook. And so we parsed out the text. It's in Markdown format. Now what do? Now we set up Astra. Right? This is basically just setting up the storage system so that we can we can dump stuff into it, and then I'll show you how to actually go from the Markdown format into a format that we can put into Astra. So here we set up two vector stores. I deleted these, so we're recreating it right now. One is called Advanced, which is the pipeline that uses LlamaParse, and then the other is called Base, which is just a baseline we're going to compare against. The baseline actually doesn't use. I think it doesn't use LlamaParse. Oh no, it does use LlamaParse, but it doesn't do like some of the advanced indexing retrieval. Mm-hmm.
Nice.
So yeah, it's created. What happens is if it doesn't exist, it'll actually hit the endpoint to try to create the collection. And then the next piece is, okay, so for the advanced indexing pipeline, we're going to define what we call a Markdown element node parser. So this is exactly why we extracted the text out in Markdown, because what this node parser will do is it will take in these documents in Markdown format and basically extract it out into a set of nodes. And so if the Markdown has easily parsable sections, text chunks, as well as tables, this will explicitly go in, extract out both the text and also separate out the tables, extract out text summaries from the tables, and also split the text by roughly even sections. Right, and so I can give you a little bit of a flavor into what this looks like. And so I'll just run maybe this. All right, so this is just like what the first chunk looks like. It's parsed out Markdown. This is another one. This is another one. And then at a certain point, there are just a bunch of tables. So for instance, like this is actually just a table of contents table. And what we see is we extract out both the text as well as the underlying table as well. So it gives you more advanced parsing capabilities. And the actual technical details we might save for beyond this talk as well. But high level is having a structure allows you to parse out like independent objects within the document. And by being able to parse out the independent objects, you're able to represent the entire document in a more sophisticated way than just doing some like naive chunking. And the naive chunking is exactly what happens in the baseline. And the issue with naive chunking is you just end up like just splitting the text arbitrarily. And so you end up like potentially, splitting things down the middle that you shouldn't really be splitting. And this leads to worse performance.
Like just to play it back for folks that are watching, like, I mean, should I assume that like if there's a table of data like within this document, right, that like it wouldn't be split like, I mean, maybe if it was arbitrarily large, it could be split, but if it was a reasonable sized table, like that would be its own chunk that would then sort of be embedded and sort of inserted in the database.
Yeah, we the nice thing about this is we try our best to basically preserve tables, and so that we preserve like the entire structure of these tables. This actually gives you the ability to run different types of queries on top of these tables using LLMs. So for instance, you can directly dump all the text into the prompt, or you could run like pandas or SQL operations on top of the table as well.
Okay. All right. Awesome. So basically, yeah. So it seems like what you've got set up is, you know, two different examples of LlamaParse being used and data being stored in Astra. One with kind of more of a naive implementation of you know, parsing, chunking, and storing the data, and the other one sort of using LlamaParse like as recommended, right? So I'm assuming like we're gonna transition into sort of like the payoff, right? Where we're gonna kind of see like how the chatbot performs.
Yeah, exactly. And so, you know, we built two indexes. The recursive one is the advanced one. The raw one is the, you know, the baseline. And so this one just uses a convenience function that does like naive parsing and chunking. And this one directly uses the outputs from, you know, our advanced parser, our markdown parser. So we'll run this, right, and it'll generate what's happening is it's going through all the chunks for both indexes and using the embedding model to generate embeddings for all these chunks, and then storing it into vector store, which is backed by Astra. And then the next piece is, you know, we'll define basically these two retrievers on top of the advanced and also the baseline index respectively. Both will have access to some sort of re-ranking module. A re-ranker, for those of you who don't know, is just a general thing you should probably add on top of your retrieval system to basically refine and filter the results a little bit more so that you make sure you're actually getting top quality retrieved results when you actually try to return relevant context. Right, so you don't stuff the LLM with a bunch of irrelevant stuff. And so they both use a re-ranker. And for the advanced capability, we have what we call like we're just calling this the recursive query engine, just due to the nature of how the data is organized. That's the more advanced approach. And then the raw query engine is a baseline. Okay, so now let's actually go through and try to ask some questions, right?
Nice.
And so we're using LlamaParse as, again, like this LlamaParse powered RAG pipeline to try to ask some questions over both pipelines and then see what the answers are. And so, you know, this question basically is just like, what is the cash paid for income taxes, net of refunds from supplemental disclosures, cash flow information? It's a relatively specific question that actually, you know, makes sense if you look at the actual table that it's sourced from. I could dig this up in the source document as well. But basically, you know, what is the cash paid for income taxes, net of refunds? It's highlighted right here. The supplemental disclosures of cash flow information. And you see, you know, roughly speaking, if we run this, like the correct answers, by the way, is these two things right here. And if we go into the source document, yeah, it's right here. I found it. So supplemental disclosures of cash flow information. Cool.
I feel like we need a drum roll or something, right? Like I just, you know, let's see what happens, right?
Yeah, I mean, I already pre-ran the results, but I'll run it again. So hopefully, you know, it doesn't break. So with the basic query engine, you see that it's not explicitly provided in the supplemental disclosures of cash flow information. So, you know, through some sort of more naive indexing retrieval algorithm, you're not actually surfacing the right chunks so that the LLM can really, you know, give you back the correct answer. But with like the markdown parser, where you're actually preserving the tables, synthesizing proper summaries from it, and, you know, generally feeding that and integrating that with the rest of your retrieval pipeline, you're able to get back the right result.
Nice. That's awesome. What is it? I'm sorry. Like, what is actually? If you scroll back up, like, what is actually rendering right there? Like, is that?
So this is just verbose outputs.
No,
Yeah.
no, no. But I mean, the thing that you highlighted, like the blue and the white bands, like, what is that? Is that like markdown being re-rendered?
The blue and the white. Are you talking about? Oh, this thing.
Yeah, right
Oh
there.
no, this is just what the table is. We just took a screenshot of this table. Yeah.
Okay.
No,
Okay.
we didn't render anything. We just took it. We like pre-loaded the image as part of this notebook.
Oh, gotcha. Okay. Yeah. No. Very cool. I didn't know if it was well, because like a lot of times with RAG, you're, obviously you have a query and you're matching certain documents, and the match is happening because of the vector matches. But then what you're actually storing in those documents is oftentimes the plain text of like what was turned into a vector. And I thought maybe that was what you were sort of re-displaying there.
So we do have, there actually are cookbooks for fuzzy matching back to the source document. But if you want to look at what the source text looks like, this is what, you're right. It's basically the process text, right?
Yeah, no, that's awesome.
And then from this process text, you could, like for instance, with SEC Insights, which is one of our demo apps, you can basically translate this back into the source PDF into PDF highlights. So that's a cool capability that we have. But this by default is just a source text.
This is super cool. And what are you seeing users do with this?
I think, the whole point of LlamaParse is, like, by the way, with LlamaIndex, you can basically build any sort of advanced QA capabilities over your data. So we see a lot of people doing more fancy stuff than what we have right here, like doing agents, being able to process like multiple steps. Specifically for a LlamaParse, what we told users is just throw in your hardest PDF. And we're still working out kinks. Like obviously there's going to be a very long tail of edge cases with just like degenerate PDFs that you like this thing can't quite handle yet. But for a lot of these, it's actually able to render out like the tables quite well. And then you can basically do stuff like this over it.
Awesome. Jerry, that demo is killer. I think you can go ahead and unless you have more stuff to blow our mind with.
No, I mean the other ones. I feel like it roughly got the point across. If you want to take a look at the other examples, I'll share the link in the chat right now, actually, as we pass on to the next speaker.
Yeah, no doubt. Yeah. So Jerry, don't worry, folks. Jerry's going to share links in the chat. We'll also. Don't worry if you're missing things in the chat. Like, we'll follow up with an email with like all of the resources that we're sharing. I should have, that should be part of the housekeeping up top. Like nobody needs to panic about taking notes or anything like that. Everything that we can share, we'll make sure to email out to everyone after the live stream. But yeah, I think now we're gonna sort of transition over to Jeff, who's gonna show us an example of an app that him and his company built on top of LlamaParse and Astra DB and a lot of the stuff that you all have seen. So yeah, Jeff, feel free to go ahead and share your screen.
Thank you. But before I do, a question for Jerry. With LlamaParse being kind of focused right now on PDFs, what's the advice you're giving to people if they wanted to do document understanding over Word or?
Oh yeah. I forgot to mention that part, didn't I? Okay, well, so the one thing so we're launching this tomorrow, which is expanded support for like 10 plus file types, which is docx, PDF, PowerPoints, like HTML, XML, and basically a lot of the common document types.
That was a good setup question, Jeff.
No, I literally didn't know that.
That's
awesome. Very cool. And I'm sorry, is that available today?
No, it will be available tomorrow. We are currently putting some finishing touches on top of it. Yeah.
Excellent. That's awesome. Yeah, we've been doing conversions to PDF for other types to get it through, but now I know what some of our roadmap's going to look like for the end of the week.
For sure. Yeah.
Thanks.
Hopefully then you don't have to do it yourself.
Awesome. Okay. So I'm gonna hop in and just show a little bit of like what Imprompt is and kind of talk from a product owner's perspective of like our journey through this. Yeah, so let's hop in here. All right, am I sharing? Can everyone see?
Yes.
Excellent. Okay, so Imprompt starts off kind of looking like just a regular old chat session. You know, let's see if I can. Right. You know, the obvious, first difference that you'll see is that we're letting you pick different models from all the different vendors and bring your own model and that kind of stuff. As well as, speech recognition and the typical text to speech and pick voices and so forth. We're really gearing this for the enterprise. So for us, it was important to be able to also reach in to all of your APIs, right? We look at this and say, the average enterprise has almost, 10,000 enterprise IT apps in production. This is large enterprise. And we wanted the ability for you to basically do the language model to API in a really rapid rate. So that's what we're calling apps. It's what some people might call tools or plugins or so forth, and the ability to turn these into flows. What we found in building this out, though, was just kind of talking to LLMs wasn't that valuable, and that quickly we had to move to more advanced capabilities. So the first innovation that we emphasized was this using prompt blocks. And I'm just going to give you an example. You can see all these blocks that we have. I'm going to go ahead and take a few of these and I'm going to add them basically to the context window. So each one of these pound somethings represents a block of text that's going to get used. Add a couple of them in here. And then I'm going to say something like, write a press release using, I'm just going to say write a press release. So you can see here that the asset count is 3. That means that it's pulling in 3 different pieces. And although the prompt was write a press release, it's using all of the context that I gave it in those prompt blocks, be able to do something that was way more contextually relevant, right? So then we had to kind of keep going because all of this is heading towards multimodal. So add images, and specifically here, add files, right? And for us to add files, what it meant was we had to be able to basically put in an entire RAG pipeline for us for our shared multi-tenant version. We own that RAG pipeline. We do it ourselves. In our enterprise version, we basically say, bring your own RAG pipeline and vector database, and you can swap in and use it yourself. I'm going to come back, and I'm going to go exercise one of the files. So just to save time, I went ahead and put in one of the Apple files here.
People love their 10Ks.
They really do. They really do. And I'm gonna drop in a prompt. I'm gonna say, who's this 10K for? And the answer should be Apple. Some of this gets a little bit more complicated though when you start doing multiple questions, because you can picture what's going on with the RAG trying to extract different chunks from different pieces of the document, and suddenly the complexity goes up, right? I'm going to do a third one here. Now I have a multi-part question. I'm using that document as part of the context here. It's going to take a little bit more time. It'll give you a feel for how much more time as you watch this thing go. But it wasn't that bad, right? And in this specific one, now I'm using the RAG pipeline with DataStax and LlamaIndex against that 10K on GPT-4. If you want to see how it works on other ones, you just tee them up, right? I'll go ahead and tee up Claude 2 as well and Mistral Medium. And we're just going to come take a look and see how they're all performing. Feb 8, 2021, risks related to and COVID-19 and so on. and we're getting pretty similar results. Now, this isn't always the case. If I try some of my guess is Command Light and Titan Light probably wouldn't do so well. I don't want to show that off, but you get the gist of what we're doing here. So that's a quick demo. Again, all we're trying to do is just bring in data from the outside that does not fit inside of the context window. It's the context window problem, and we resolve it with RAG. Everybody always asks us, are we just going to wait for huge context windows? And my answer is always no, we're not. It's slower inferencing, it's more expensive, and we found it more difficult to debug. The other thing that I tell everyone is it's not just chatting with files, because what happens here is you end up chatting to assistants, or you chat to an agent, and those agents use tools, and those tools might return files. So my emphasis is make sure that your RAG pipeline is like a shared service across the portfolio. Don't just think of it as chat to files. So from our perspective, we're using LlamaIndex and LlamaParse. I'm so happy to hear that it's multiple file formats. It's been easy. We're looking forward to getting some strong SLAs and cloud solution available in multiple VPCs. So I spent a few years in computational linguistics, and the problem that LlamaIndex is tackling right now is called document understanding, right? And if people are super interested and unfamiliar with it, you can search document understanding and maybe NLP and get some interesting insights. But the gist is they're doing a lot of heavy lifting around convenience loaders and chunking options and efficient embeddings. And it's, and the set of concerns that they have to solve is continuing to grow, right? Figure understanding and these anaphoric and cataphoric references and all this stuff. From my perspective, it was just, I'm so happy to have a vendor, a technology partner who solves all these things for me. On the Astra DB side, we have to run a production grade service. So I wanted to make sure we had something that was available in multiple clouds, low latency, high resilience. We're in a hurry, so I wanted white glove onboarding. Everyone knows that this stuff is moving so incredibly fast, right? That whoever your technology partner is, they have to be working with the ecosystem providers. We want to make sure it's affordable, pass on the savings to our customers, and we're just huge fans of serverless. So, we basically said we wanted to make sure that whoever we went with as our technology partners, that they were up on all the new stuff, but also that they knew how to run a highly reliable service. That was what we were really getting at. And we did it, right? So we pulled it off. We were able to work with both LlamaIndex and DataStax to get this into production in very short order, and we ultimately released the chat stack for AWS. So this is our solution. It's basically, we have the SaaS edition, and we have a second one where you can push the button, kind of boot this thing up into your own AWS region and get your own. That's what I got going.
Awesome.
Yeah, thanks.
Jeff, that was super, super cool. A couple quick questions. First of all, for everyone who's watching, and especially in Crowdcast, there's a button right down at the bottom of the screen that you can use to sign up for Imprompt. So, well, it was there, but don't worry, there it's back. Thanks. Jeff, how many, I'm sure, I don't know how long you've been thinking about Imprompt and imagining it, but how long have you spent building what we saw, roughly? How long did it take to kind of go from a pretty clear idea of what you wanted to build to what we just demoed?
It's a funny thing. I was looking at my old emails, and I was clearing out the inbox, and I found the note in 2016 to Greg Brockman and Ilya, co-founders of OpenAI, about trying to get some of this stuff going. So the journey of where large language models was going to intersect with corporate enterprise IT has been 8 years or something. what we built just here has been in the last 12 months. We put a lot of emphasis on the plugin capability, or whatever you want to call it, the language enablement of it.
Yeah. Okay, awesome. Well, look, that was a killer demo. We're 5 minutes over our 45-minute sort of self-imposed deadline, but like we're not done. So I think we're gonna spend the next 10 minutes to close out this live stream. And we just have a ton of questions that people have asked. And I know we're gonna dive into a bunch of like hot takes. I think we should try to address the questions that folks have brought up in the chat. The top one is, are we going to get a copy of the LlamaParse demo code? Yes, don't worry about it. We'll send it out. It's been shared in the chat. We'll send it out in the emails. Don't sweat that. I'm gonna kind of run through these. Let's see. What would be working architecture for embedding JSON at runtime? Or are people mostly embedding more real-time data in batch? I'm not 100% sure what that question means. Be honest.
I don't really know if this answers the question, but basically I think, I think for a lot of document use cases, it tends to be less like real time. So it's not like streaming real-time event data. It's more like, you have some PDFs that you want to index, and these PDFs might update, like if you point to your, S3, like GCS bucket or something, like you're able to just like point that and then maybe periodically refresh it like once a day or so. And I think that's a common pattern we're seeing. I think for real-time event data, that is probably like a different architecture and tends to not be like the input types tend to not be documents. It tends to be like user events or something.
Yeah. Okay. Yeah, that makes perfect sense. Cool. So this next question was, sort of a question about like, creating prompts about like cache or cache equivalents. And I think Jerry basically demonstrated exactly like how easy it is to kind of ask that question, and kind of demonstrated like how you can get basically like non-answers or bad answers when you're not structuring and chunking your data appropriately versus like when you are using something like LlamaParse. So I think we covered that one. Oh, this is interesting. Would the chunking provided by LlamaParse support more semantic structures for the embeds, similar to Raptor, or is the Raptor plugin the way to go in order to separate data into different domains? Like, I'm not familiar with Raptor, but I mean, it does bring up a reasonable question that there are so many different sort of DSLs or like ways to structure data. So like, kind of what's on your roadmap in terms of being able to parse more kinds of data?
Yeah, so the way Raptor works is it hierarchically organizes your data in a tree. And we have a Llama pack actually showing this, and we just had a webinar with the Raptor authors last week. LlamaParse, the main job of LlamaParse is just to get your data out of a PDF into some format, whether it's markdown and JSON. And on its own, if you just use LlamaParse, you can do whatever you want on top of the data afterwards. So you could, in some world, like take LlamaParse, take the JSON outputs, and basically create your own Raptor indexing on top of that data to organize it into some tree. And so, if we take parsing, and then there's the processing, like the processing ingestion piece, all that stuff lives on the open source. And so you have a lot of flexibility. You could either use our out-of-the-box modules, or you could write your own to basically process that data and put it into like a vector database.
Okay. Awesome. I feel like there's a rapid fire like Jerry session we're having right now. Hey Jerry, is LlamaParse able to do OCR on images?
Yes. And if you run into issues, let us know.
Okay. All right. That's super cool. Let's see.
Jerry, that sounded like a maybe.
No, it does. It does.
It's just
I mean, I can't guarantee it's going to work like 100% of the time, but like, if you run into issues, that's what.
Well, how is that sort of implemented behind the scenes? Like, what is I like the reliability? Like, what are you using to attempt the OCR in the first place?
I mean, I think we're using some OCR implementation that I can't really quite disclose yet, but also we added some stuff around like language support. And so I think one part where it used to struggle at was being able to parse like stuff in just like a different language, especially like different alphabet. You parse like Chinese or like Arabic or something, it wouldn't do as well. So we tried to resolve that, but I think that's also something where, if you have feedback on that end, let us know.
Okay. All right. Awesome. And then I think we'll kind of close out the questions. Thanks everyone so much. this is only our second time doing these live streams. It's been super fun, and we've had way more questions today than we had our first time. So thanks for asking them and being engaged. I guess we'll close with this one. Like there's a question about like really complex tables. I feel like this is a bit of an edge case, but someone's asking like, what happens if you have a table where like inside of a cell there's almost like another table? Like, is that something that, you know, that LlamaParse like will sort of be able to kind of grok and understand, or is it just kind of hopelessly like too much of an edge case?
No, for sure. I mean, people have asked for that. I don't know if we really support that well right now. But I think realistically, if we do parse it, say into some sort of JSON, it'd probably be some like JSON dictionary of like a table, and then within there, there'd be like more like another like sub dictionary with like another table. At least by parsing it that way, you have some flexibility in how you want to process it. Yeah, I don't think we are able to support that super well yet. However, that is actually something that people have asked for.
Okay. All right. Awesome. All right. So I think we're gonna close it with the questions. I think that kind of brings us to like a nice close. Jerry and Jeff, like, before we sort of sign off, like, are there any sort of like, you know, kind of call to actions or things that you would suggest people like check out or look into before we close out? And we can start with Jeff.
Yeah, I think my only recommendation is to think about the test cases early in the process. So what was key for us was to build a test suite and to think about it from a test harness perspective. You get different answers based on, you know, the permutation of how you go do all this. So yeah, just building the test suite will be your friend in the long haul.
Yeah, test-driven development is super important. Yeah, I mean, definitely check out Imprompt.ai, especially for, you know, the like a really nice end user facing experience. And I think the call to action would have just been to, yeah, check out LlamaParse. We have some exciting updates coming this week, especially with uncapped usage, expanded file types, and also template extraction. So yeah, definitely check it out. Try out your favorite, most complex PDF. Try out like building a RAG pipeline over it, and let us know.
Awesome, cool, and as we've mentioned several times, like, don't worry, we will send out an email with links to all of these awesome resources. I'd say from the DataStax perspective, I mean, my call to action for all of you is just to, you know, keep experimenting and building on top of all these tools. Like, speaking of myself, like I'm brand new to generative AI. I didn't start looking into any of this or learning any of this until this past December, I'd say. As opposed to, you know, someone like Jerry and even Alex that have just sort of been in the space a lot longer, or a Jeff, you know, who apparently has been emailing like the founders of OpenAI, like, you know, from like 9 years ago. So this is all relatively new to me. One thing that's kind of, you know, maybe intimidating or sort of something that kind of creates friction for me is like how fast everything is changing. You know, it kind of feels like by the time you learn something, you know, it's a little bit obsolete. Or at least I think that's how it felt maybe a few months ago. I do feel like things are, I think Jerry might agree. I think things do feel like they're solidifying a little bit. I feel like there's more best practices and and tools are sort of like becoming more GA in terms of all of these different parts of what it means to build a Gen AI app, right? Like ingestion is like, it's kind of gone from a bunch of different radical ideas on how to do it efficiently to tools and techniques that are feeling like more standardized and producing like better results. And that's kind of what we talk about when it comes to, you know, making things production grade. But anyway, so my ask to all of you is like, don't be intimidated by this stuff. Please check out the resources that we share. Like, have fun with your own documents, have fun using LlamaParse to do different things. Have fun storing different kinds of data in Astra DB and playing with similarity search. The tools have never been more accessible to more kinds of developers than they are right now. This kind of stuff was, you know, you had to work at Netflix or Amazon, you know, 5 years ago with a whole giant engineering team and, you know, millions of dollars worth of servers in order to build like a single like recommendation engine or to do any of the stuff that we're describing. Like right now, you know, with LlamaParse and Astra DB and other tools, you know, you can do this stuff right now in a free Google Colab notebook and like have like and generate like pretty amazing results. So yeah, I just encourage everyone to check it out and have fun with it. And I think that's it. So I think we're going to sign off. I want to thank Jeff and Jerry for joining us on the live stream. We love doing these things. I want to thank everyone for kind of taking some time out of their day and taking time away from work to tune in and hang out with us. And we look forward to talking to all of you next time. So take care. Bye, everybody.
Thanks.